Okay, so in this lesson, we're going to be looking at exponential transformations. So like the transformations we've looked at in all the other functions. So the basic exponential function is y equals b to the x power. Anytime it's exponential, that means x is a part of your exponent. Okay, notice that b, which is your base, the number or term that's directly in front of your exponent, has to be greater than 1 and cannot, or greater than 0 and cannot equal 1. So there's three different types of exponential basic base functions. So with the base 2, it's 2 to the x. With the base 10, it's 10 to the x. And then base e, which Euler's number that we talked about, is e to the x. So we're going to complete the table for the most basic 2, 10, and e for your exponential functions. So if we look at this one, I know it's been a while since we talked about the parent function. I'm just going to go ahead and just make a table here. I know we already have the graph just to kind of refresh our memory. So if I were to plug in a -2 here, I would have 2 to the -2 power, which remember we move, and we would get 1 over 2 squared. So that would be 1/4. If I plug in a -1, that would give me a 1/2. If I plug in a 0, remember any number raised to the 0 is always 1. So 2 to the 0, 10 to the 0, e to the 0, they all equal 1. And then if I plug in a 1, 2 to the first power is just 2. And then 2 squared is 4. So notice those points are plotted on the graph. I just wanted to kind of refresh our memory on what our parent function table looks like for that. So the asymptotes. Notice that there's not a vertical asymptote, but there is a horizontal. Notice this graph is approaching the x-axis, so the horizontal asymptote would be y equals 0 because it crosses the y at 0. Also notice this is a growth. Remember we talked about it. The base there is greater than 1, so it's a growth. It's increasing. Intercepts, notice it does not cross the x-axis because that's your asymptote, but it does cross the y at 1, so that y-intercept would be 0, 1. And then your domain, looking at it, is continuous to the left and right, so you can either write -infinity to infinity, or you can write all real numbers. Okay, so the range, looking at it, it's all the positive values, so you can either put from 0 to infinity, not including 0, or you can put y is greater than 0, so I don't really care which way you write it. Okay, so that's the parent function if the base is 2. The parent function if your base is 10 to the x. This is what it looks like on a graph. You could also plug in some values if you want to get the table. So looking at it, the asymptote is still the same. It's still approaching y equals 0. Notice it also has a y-intercept of 0, 1. The reason for that is because remember we said on the last one, anytime I raise something to the 0 power, it always equals 1. Excuse me. So looking at our graph, notice this would be domain, all real numbers are -infinity to infinity. And then your range, it's also the positive value, so either 0 to infinity or y is greater than 0. Okay, so last one that we're going to look at is if your base is e, the parent function is e to the x, very similar than all the others. So you have a horizontal asymptote at y equals 0. You have a y-intercept. Notice it's at the same point. Your domain does not change. And your range does not either. So again, it doesn't matter if you use interval notation or inequality, whichever one you prefer. Okay, we're going to go ahead and flip over. So now we're going to get into some graphs. So the transformations are very similar to all the other functions that we've talked about. So anytime we're adjusting the x, whether it be in parentheses, under a radical, in the denominator, it's always a horizontal shift. If you are adding or subtracting outside of the parentheses, the radical, the fraction, it's always a vertical. So it's very similar to exponential. If you are adjusting your x in the exponent, that's going to be a horizontal shift. Remember, that's always the opposite. So our transformation would go left 3. And then outside, notice outside of the exponent is a minus 6. That would be down 6. Now, this 2 is a part of our parent function, 2 to the x, so that don't confuse that with a vertical stretch by 2, because that is our normal base of our parent function, okay? All right, so we can graph this a couple of ways. First, we'll graph it with the transformations, and then we'll graph it on the calculator. So I'm going to go ahead and shift left 3 and down 6. That is my new origin point, which is also where my horizontal asymptote will be, because it has to cross through the origin point like on the parent function that we looked at on the front. Okay, so since that's my new origin point, if you remember from the front, we made a little table to review ourselves for 2 to the x power. That was negative 2, which gave us 1/4. So I'll go left 2, up a fourth. And then negative 1 was 1/2, so I'll go left 1, up a half. 0 was 1, so don't move left or right, just go up 1. And then 1 was 2, and 2 was 4. So go right 1, up 2, and right 2, up 4. So there is our exponential graph. Okay, so that's how we can do it based on our transformations. So shift it, and then you can find your new origin point and plot those points. We can also use a calculator, so I'm also going to show you how you can do that so you can look at your table and plot your points for that way. So we're going to go to calculator. Let me find my camera roll. So go to y equals. We're going to type in the function. The base is 2. We're going to use the caret symbol, which raises it to a power. I'm typing in the exponent, which was x plus 3. Make sure the whole thing is in the exponent spot. And then use your right arrow key, so that way we can do the minus 6. Okay, so now I'm going to you can press graph if you want to look at it to make sure it looks similar to what we already have. And then I want you to also go to your table. So second graph will get you to your table. On the table, it's starting with negative 6. So I'm going to have to go back to my notes to fill those in, but notice those points are there, so we would just go to the table to find those. So I'm going to go back. So when x is negative 6, our y would be negative 5.875. Negative 5 would be negative 5.75. Negative 4 would be negative 5.5. Negative 3 would be positive 5. Negative 4. Negative 2. And 2. That should be negative 5, my bad. Okay, so notice you can actually look at these and see that 0, negative 1, negative 2. Okay, so you can compare them that way. So I will allow you to use a calculator to plug those in. So notice that our horizontal asymptote moved because our graph shifted down 6. So now it's crosses the y at negative 6. And then our domain, notice our domain of any of these exponentials are going to be the same every time. It's going to be all real numbers or negative infinity to infinity. So it's going to be the same every time. And then your range, it's going to be all of your values above 6, so from negative 6 to infinity, but not including negative 6, or y is greater than negative 6, so whichever way you want to write it. Okay, now let's move on to the next one. So notice this one, our base is e, so our parent function that we're starting with is e to the x. So starting out, I'm going to go ahead and write my transformations. Notice there's a negative, so that will be a reflection over the x-axis. And then the 1/5, it's on the outside, so that's going to be a vertical compression. And then notice nothing changed with our exponent, and then nothing was added or subtracted afterwards. So this one is a little more confusing on graphing it by hand, so I'm going to go ahead and just plug it into the calculator. So go back to your y equals. We're going to have negative, so use the negative symbol, not the minus symbol. 1/5. And then I'm going to have e, and I'm raising that to the x power. So there's two e's. We've talked about it. You can either use the one on the division, or you can use the one that is the ln button. So I'm going to do second ln, so that way I already have the exponent position, and I'm putting an x. So you can graph it to see what it looks like. And then you can also go to your table. So notice it's going down because it was reflected over the x-axis. So second table, it'll get our values for us. So on the table on your notes, it's going from -3 to 3. So we'll use those points there. So -3, -0.01. -0.0271, -0.0736, -0.2, -0.5437, -1.4778, and -4.171. All right, so we're going to go ahead and graph it. So -3, -0.01, Notice that as you look at these points that are right here, they're getting closer and closer to your x-axis, so you know that that is going to be your horizontal asymptote. Also, notice that since we didn't shift it up or down, it's not going to be changing our horizontal asymptote. So our horizontal asymptote will still stay at 0, y equals 0. Your domain, which I've already gone over, remember your domain of an exponential is never going to change because it's going to be continuous to the left and to the right. So -infinity to infinity were all real numbers. And then your range on this one, it does change because it's reflected over the x-axis. So it's either going to be -infinity to 0, or you can put y is less than 0 because it's going to be reflected over that x-axis point. Okay, so on the graphing part, you're welcome to plug that in the calculator, find those points. Your transformations are the same as all the other functions that we've been talking about. Okay, flipping over. Now we're going to be given a parent function. We're given a new function. We're going to find the transformations by looking at the function, and then we're going to find the domain and range and any changes. Okay, so part A, we're starting with 10 to the x. We are going to go to this one. So notice in the x, it says x plus 1, which means it would shift the opposite and go left 1. The plus 4 on the outside means you're going to be going up 4. And then the 10, remember the 10, notice that's my original base on my parent function, so I do not need to confuse that with a vertical stretch. So remember the domain, same every time. Your range, since I'm going up, It is changing it. So my range is now going to be either, you can either put 4 to infinity or y is greater than 4. So whichever one you think is easiest to write. My asymptote did change. Since it went up 4, that means my asymptote is now going to be at y equals 4. So if there's a vertical shift, you know your asymptote will change based on that shift. Looking at the next one, I'm starting with e to the x. There's a negative, which means a reflection over the x-axis. Now notice that 2 is not the base. The base is e, so that will be a vertical stretch by 2. And then in the exponent, it says x minus 6, so it will go right 6. Domain's not going to change. Your range, notice it did not shift up or down, so the range should still be the same. So you can either write, since there was a reflection over the x-axis, that does change the range, but it's still approaching 0. So that would be negative infinity to 0, or y is less than 0, because again, there was a reflection over the x-axis, so it should be going down now. This is what I meant by didn't change. Your asymptote didn't change. It's still at y equals 0. Okay, third example. So we start with 2 to the x. Notice there's a 2/3 in front, so that would be a vertical compression by 2/3. That 2 is a part of the base. That is the base. There is nothing with x in the exponent, so it's not shifting left or right. Minus 12 out after the exponent is going to go down 12. Domain will stay the same. Range will not stay the same. It went down 12. There wasn't a reflection over the x-axis, so it will be negative 12 to infinity, or you can write y is greater than negative 12. Asymptote did change. It went down 12, so now it's at y equals negative 12. Okay, looking at this next part. Now we're given the transformations. We're going to have to come up with a new equation. So this one we're starting with e to the x. So we know we'll have an e in our equation. It's going 3 units to the left and 6 units up. So writing your equation, we have an e as the base. Since we're going left 3, we're going to do x plus 3 in the exponent, and then up 6, we're going to add 6 afterwards. Domain is not changing. Since we went up 6 and there's no reflection, that means we're going to be going from 6 to infinity, or y is greater than 6. Again, you don't have to write both of those, just decide which one you think is easier. The asymptote did change because it's a horizontal asymptote. It went up 6, so now it's at y equals 6. Okay, next one. We're starting with 2 to the x. We're going to reflect it over the x-axis, vertically compress it by 1/3 and go down 20. So writing your equation, we know we'll have a 2 to the x in our equation. The reflection puts a negative in front. The vertical compression puts it in the very front of your base, so 1/3. Then I times it by the base 2 to the x. It's going down 20, so it didn't shift left or right, so I just have x in the exponent, and then I need a minus 20. Domain's going to stay the same. Range, it's going to change. It's going down 20, but it also is reflected over the x-axis, so it's going to look something like this. and it'll shift down. So it should be, your range, depending on which way you want to write it, should be negative infinity to negative 20, or y is less than negative 20. And it might be that this is the easiest here. It's always going to be less than if there's a reflection, or greater than if there's not a reflection of wherever it's shifting. Your asymptote went down 20, so it would be at y equals negative 20. All right, this last one, I want you to try it on your own. Go ahead and pause it. And then once you're finished, you can resume and see if you got it right. So you're starting with 10 to the x. It's vertically stretched by 250 and up 1500. So we have our equation, g of x equals, vertical stretch goes on the outside, so 250 times our original base, which our parent function on this one is 10 to the x. We're going up, so you need to add 1500 after your exponent. Domain is staying the same. Range, we're going up 1500. It's not reflected over the x-axis, so it should be 1500. Oops. Put the comma in the wrong spot. 1500 to infinity, or y is greater than 1500. And then your asymptote changed, and now it's at y equals 1500. Okay, so these are our transformations of your exponential functions. There's 3 different types of bases you can have, 2, 10, and e. If you have any questions, please let me know.